Most people think AI is going to fix the grid. My guest today builds the technology, and he tells me the opposite. AI does not fix a broken system. It runs the broken system faster. Welcome to the O'Brien Brief, the show where operators talk about how results are actually built. Not the theory, the execution. I'm Tony O'Brien. My guest today is Devin Hedge, founder and CEO of Calatüré. Devin spent his career in software delivery, the hard mechanics of getting complex technical work shipped. Then he pointed all of it at one of our hardest problems, the electrical grid. He's building what is called a virtual power plant. And if you do not know what that is, you will by the end of this conversation. Here's why I wanted Devin and I come together from opposite worlds. He's an engineer. I ran a 400-person sales force across 13 deregulated energy states. And we arrived at the same conclusion from different doors. A is not a magic wand. Pointed at a broken process, and it just breaks things faster. He says it's about the grid. I say it's about revenue. Today we get into both. Devin, welcome to the show.
Good to be here. Thank you, Tony.
So give the people a short version of your path. Years into software delivery and then energy. What was the moment that you decided this was the problem worth building a company around?
So I started years and years ago not wanting to be in power systems engineering. I literally decided to flunk out of college because they didn't have another electrical engineering program that wasn't power systems engineering. So I took a different path, a circuitous path. Went in the military, got involved in communications, came out, went back to school, focused on business and communications and MIS, and it was just a match from there on. From there, my senior year, though, in a kind of stroke of irony, I ended up working in power systems engineering on a project for my really good mentor. Flash forward 30 years, and I'd worked in every industry, focusing on agility, focusing on basically building systems that are resilient and adapt, and not just on the IT side, but also the IT, OT, and the business all together. How does everything adapt very quickly to market conditions? And frankly, I only saw two successes in that 30 years. Which tells you just how hard this problem is. But those two successes taught me something very, very valuable, which is it can be done, first of all, and that if you play with go with what's there, right? Understand what's there, understand what's broken, understand why things are built the way they are for resilience today, then you can actually figure out where to change, what levers to pull. And that was it, right? So I didn't want to rip out the grid. I never wanted to come in and rip out the grid or disrupt the grid, but I realized that, well, first of all, that's impossible, right? Everything that's there. What I wanted to do, though, is build a greenfield intelligence layer that sits on top of the brownfield and then finally manages it. And the idea originally was, let's use AI because it's the hottest thing. And I'd been playing with AI since I was a kid in some form. So to me, this was just, okay, let's keep it going, keep extending it. But what I ran into is that, you can use it to decarbonize, you can use it to build agility, but it pointed at a white hot spotlight almost immediately that the infrastructure wasn't built for agility. They're not incentivized for that. They're not measured for that. And so when all of the pressure started coming for building out AI data centers and then bringing manufacturing back to the United States and the tremendous amount of modernization that needs to happen on the power grid, I said, I'm going to use my agility skills here. I'm going to try and use AI, but the way I'm going to do it is I'm going to focus on virtual power plants and microgrids to cobble things together in such a way that I'm abstracting myself from the power grid itself, letting the power grid modernize at the pace that it's going to go, but at the same time isolating clients away from the power grid and the lag there and allowing them to go as fast as they can go using other modern technologies, preferably renewables.
That's in depth. So let's take that a little further. Our listeners know nothing about the conversation of the subject. How do you describe Calatüré? What do you actually say to describe your company?
Calatüré is really more of a holding company than anything. The virtual power plant is actually just a division. So we build, design and build, and then run the virtual power plant. So what is a virtual power plant? Well, it's a term that's been around for a while, but it takes two big concepts. We knit together a lot of small, what are called distributed energy resources, which is solar, batteries, backup generation, different ways to do flexible loads. And we pull it all together so that the power grid itself only sees this edge of where we're at, and we're controlling everything behind it. We can actually sell excess energy to the power grid in the markets that allow it, or we can reduce the demand from the power grid by actually generating and storing our own energy behind the meter, which actually creates a win-win, because what we're doing is we're giving the distribution grid or the transmission grid resilience by letting them have the opportunity to either buy additional generation from green sources or not have to generate or build out even excess infrastructure in order to meet the demand, the increasing demand.
You run this lean, mostly contractors and AI structured, kind of like a Silicon Valley startup. Why that model for something as heavy as energy infrastructure?
So I spent 12 years teaching really, really, really big multinationals how to dance like a lean startup in Silicon Valley. I was trained at the feet of the people who started the Agile movement and signed the Agile manifesto. And I said, okay, how do I extract that? Well, some of my friends have helped some pretty big name manufacturing companies apply those same principles to manufacturing. And I said, how can we do it to systems engineering? And that was the, I'll call it the challenge that I saw about 5 years ago. And I said, I'm going to figure this out. And so why that model? It allows me to basically run as a very lean, very greenfield company instead of tying myself down to the same principles that a legacy or an incumbent utility would have. I just start from the principle of this is the goal. Here's how I'm going to test all of the things that I have to do to meet that goal. And I'm just going to keep staying the course and pivot until I get to the goal. And I have to be honest about the trade-off though, because using contractors and AI gives me elastic expertise, and I bring these deep specialists, to the table so that I don't have to bind them up. But the challenge with that is, and it always has been, the moment that contractor goes away, that knowledge goes away with them. So that was actually why I started the company in a different route than a traditional Silicon Valley lean startup. Traditional Silicon Valley lean startup gets the smallest piece of a product out the door as fast as I can. I did something different. I said, I want to get the mechanism for validating the problem space and retaining the knowledge and creating a learning loop using AI, which AI is actually good for that. Since it was greenfield, I wasn't bound by anything but the standards and the things in the market that I already knew, and could basically standardize on the different IEEE protocols and so forth, and then just iterate. How does that work? And every time I bring an expert in, everything that they contribute, the way that they contribute is interactively with the AI. So the AI is learning from them. So it's always a risk when you bring in contractors, but I think I've offset that risk. And then there's another piece to this, which is the way I bring in contractors and the way I'll be bringing in employees is you're a deep ecosystem partner. You're not just a pair of hands that I expect to show up and do a job. I expect you to learn from me, and I expect me to learn from you, and I expect to be coached by you, and I expect to coach them. And we're, basically we provide each other the value. We create the value together, and we sink or swim together. There's no, well, if it doesn't work out, the contractor doesn't get paid. No, that's not true. But basically I tie incentives and so forth to our mutual success. And that turns into a win-win no matter what. The interesting thing is, though, I do hold ourselves accountable to the outcome as a metric, and I tie that metric to the contract. So then you've got that mutual test, basically, that you're holding each other to. but the task can be outsourced in the way that AI can be outsourced and the knowledge stays internally. Is that, you following that?
That makes sense. And so let's further define this. I mean, everyone has seen power plants in their region where they live. What is a virtual power plant? Explain that to someone who's never heard that term, which would include me, by the way. The term virtual means something other than brick and mortar. Try to drill down on it just a little bit for us.
Sure. So historically, power was generated at a power plant, steam, coal, nuclear, gas, and it was produced there. The energy is produced there in a big generator and sent over transmission lines, and then it gets to a place and it gets distributed and then goes down the wire to a building or someone's house. A normal power plant is one big physical thing. We talk about the power grid as the world's largest machine, and it is. I also talk about how that if Thomas Edison were to show up today, he would look at it and he would basically recognize everything, because we haven't innovated that far besides just gone from, basically hydraulics to solid state to transistors and ICs in terms of the control circuits. So it's the control circuits then that allows me to create a virtual power plant, which is virtual power plant uses a whole bunch of small energy resources. So you can think of solar panels on one building, solar panels on another building, an electric vehicle, and I tie them together over a network connection so that they appear to the grid as one controllable device that can either consume power or can produce power, or some blend of both. So the virtual part is a coordination layer. It's not really the hardware itself. The panels, the batteries, they're real. The plant is really the intelligence that makes them move together. The analogy here, I think a good analogy is the difference between one enormous generator and a well-conducted orchestra of small instruments, right? So if you think of it, an orchestra, each instrument or type of instrument produces sound, and you put them all together, and I act as the conductor.
All right. So you kind of talked to me about orchestrating resources. I think that's what you're going at right now. Behind the meter, so to speak, which I'm assuming is very important. How does that matter to like a building owner or manufacturer? Walk us through that.
Okay, so the meter is the boundary. That's the service point where the utility measures what you pull from the grid or what you send to the grid. Behind the meter is everything on your side of that line. So if you're a manufacturer or you're a commercial office park, or if you're a data center, you have a whole bunch of devices behind that meter. Now, okay, in reality, there may be several meters, right? Because each meter is tied to a specific circuit. So how do you orchestrate everything behind that meter in order to optimize what you're getting from the grid so that you're not overloading the grid? And how do you optimize your cost structure so that a lot of markets now are using what's called time of use, so that in the peak demand periods of the day when everybody's got their air conditioner running on their buildings and they're trying to charge their vehicles and all the plants are running, that's peak demand, right? Well, peak demand keeps going up and up and up and up. By putting other generators, small generators, but useful generators, we can actually start removing the reliance for the excess energy off the grid and just move it around behind that meter from the small generator to the consuming device there on site. So it's not even going out and using the grid. That's why that behind the meter is so important. Most utilities, they're waking up, they're implementing something called advanced meter infrastructure right now nationwide. We're about 15 to 20 to 30 years behind on rolling that out. Fine. There was never an incentive really to do that until we needed to figure out what was behind the meter as a utility so that we could start forecasting how much centralized generation do we need to purchase or order in advance so that we don't have brownouts. Well, this kind of flips it on its side, not on its head, but on its side, and says, how much do you order from the local microgrid? How much do I generate local? Send that information, how much I'm going to generate local, send that to the utility so that they can update their local forecast for the distribution grid and not order so much. And if they're not having to order so much from centralized generation, then the cost overall for everybody starts to level off, and the cost becomes contained. So that's why behind the grid is so important. Plus, it gives you resilience. If you're a production line, my goodness, if you have a brownout, that's not just a little thing, right? That has this long chain of all this production scheduling that had happened, all the orders that you had there, all the supplies that are going to show up and stack up. As manufacturers and their distribution network really get hyper intelligent through Industry 4.0, this intelligent scheduling of electrified vehicles has a big ripple effect if there's a brownout there. So we're basically preventing that. We're providing safety for the manufacturer and for the data center so that they don't have to worry about, hey, there was a huge spike on demand at the local distribution grid or the actual transmission grid, or even if there was an outage, right? We provide a buffer against that outage. So that's saving money, lots of money, a lot more money than the cost of that energy.
Your AI models improve load forecasting 10 to 15%. In plain terms, what does that improvement do for the person who's paying a bill?
Okay, so let's make sure we've got some real honest framing there, right? The argument for, I don't know, as long as I've been alive, has been that, well, the sunlight's not out all the time, and there's clouds, and it's unreliable. That is absolutely true in a sense. When we started adding batteries, pairing them with solar panels, what we're now able to do is put in enough solar panels that we have excess energy. And that excess energy goes into those batteries, and we can do two things with them. We can use it to supplement the amount of energy that we're using outside of the peak solar generation time. So level the demand, or we can sell that back to the power grid, because what's kind of interesting, manufacturing tends to be a fairly level demand, right? Commercial tends to be fairly predictable because people show up at a certain time, the sun comes out at a certain time, and people go home at a certain time. What happens is that certain time near the end of the day, not everybody's going home at the same time, and a lot of people are getting home, increasing the residential demand exponentially, and the demand is still there at the commercial or industrial side. So what this is about is really trying to deal with how power companies have historically dealt with it, which is they just bought excess energy, and there was a whole lot of cost in that, and anything that wasn't used instantly literally went into the ground, back into the ground. So energy comes out of the universe through generation and goes back straight into the ground, right? So I'm saying to the power company, hey, we'll take the excess, we're going to level that, right? We're going to use solar, we're going to use wind, we may use turbines to add to that into the battery, store it, and then use it using AI models in order to stabilize the grid, not have to have as big of a buffer on the grid so they can keep their costs down. And then at the same time, we'll keep even a little bit more than that, and allows us to actually reduce our energy cost from them even further. So the goal is usually about 20 to 25. The crazy one that I modeled out, and I'm still validating this one, was doing what's called a modular AI data center. I was able to model out, I'm not sure if I believe it actually, but I was able to model out basically zero power from the grid, basically producing everything on site using hydrogen fuel cells along with different types of batteries. There's a lot of different types of batteries and have different uses for those batteries. And then massive solar farms and something called heat recapture. Historically, someone would look just at one thing and says heat recapture is very costly. It only gets this, 5-10% recapture of energy from the waste heat from the generators or from the HVAC. Well, I created a closed loop model and said, hey, you know what? 10% is 10%. If I amortize that over 5, 7 years, 15 years, what does that really look like? Well, it turns out I can then use this closed system to get really close to 85, 90% everything. I saw one model that came out 100, and I still don't believe that, but everything generated right there on site without any additional demand on the current power grid. So that solves the energy crisis right there. That's important, right?
Yeah, and most everybody would agree with you. So you rely a lot on artificial intelligence, and there's a lot of noise about AI replacing people. Now, you're building heavily on AI, and you say the opposite.
Yeah.
What do the loudest voices get wrong that you feel you have right?
Oh, so many things. So, first you have to recognize, what AI are we talking about? When most people talk about replacing people with frontier model AI, these agents, general AI agents, even maybe specialized AI agents, what they're talking about is replacing tasks, right? Tasks, not people, but tasks. Now, that got turned into somehow, somewhere along the way, got turned into, if all of the tasks are automated, then I don't need the people.
Right.
Which that's baloney, right? I mean, it's just, that doesn't even make any sense. So that's what most people are talking about when they're talking about AI. And I do have AI doing a lot of the tasks. I also have AI managing the AI doing the tasks. And I have AI, if you just think of them as virtual people, or what we call digital twins, right? But I went a step further, which was, I didn't believe that we didn't need humans. And people will tell you human in the loop. If you hear the term human in the loop, usually that means they don't trust the AI, which fair, given the way people are implementing it, that's true. You want to have a human auditor constantly there. But I went further, which was, I built the system assuming I couldn't trust it to audit itself in the way that we used expert systems years ago, only without the brittleness of the rules engines, right? And by doing that, basically, I created a self-improving, self-correcting system. The actual amount of AI in there is kind of ironic, because when I started out, it was like this big. And as it went along, the actual AI got smaller and smaller and smaller, because AI would replace itself with code. So it's nuanced, right? You cannot just throw AI at a business problem, though. If you've got and this was something I recognized years ago doing business process re-engineering. People would say, okay, we're going to come in and re-engineer this business process, and we're going to, we got this blueprint that we've come out. Here's what perfect looks like. And that always failed, right? Because one, people didn't want to do that change. They didn't want to change to what perfect looks like, because it's just not practical, right? But now we're bringing AI and saying, okay, well, AI will just replace or do better automation or do better thinking of each step in that process, so that the human doesn't have to do that. And I'm like, all you did was take whatever's flawed in that process, and you're just doing it faster, right? You're just doing it faster.
This is the whole argument of the book I just published, AI Won't Fix It, which is now available on Amazon. You're saying it about the grid. I'm saying it about sales. It's the same disease, right?
But same disease.
Yeah.
Absolutely same disease.
You've lived it on the technical side. So keep going a little bit further. Where does it bite people the worst?
Wow, that's a good one. For me, where it bites people, where I'm seeing it bite people first, is we forget that businesses are a complex adaptive human system, which relies on a culture. And that culture has an identity. And then we just throw AI at a business process, thinking that we just unplug the people and plug in the AI as if it's a fungible resource. And I'm like, that's, first of all, people aren't robots. We hired people because they have intuition. And yeah, it's messy. People are messy. People are messy. Get over it. If you want to remove all variability in a system, right, go build machines. But the problem is that messiness that is human is also the messiness that, while you may not get a standardized process or you may not get an optimized process, you've got a intuition there and an organizational knowledge that is keeping your business not just running, but is what makes it special, what makes your customers show up. And if you blow that up, and okay, there are some reasons to blow it up. right? I can find reasons to blow things up. I used to do it all the time. But you need to be very, very surgical. And I would even argue, which, I remember in your book, you made a case for this, which I thought was really poignant, which is, don't go in and just start trying to automate things. Baseline, right? You got a baseline and figure out what's actually broken. You know what? Yeah, you can use AI, a specific kind of AI, to do that, right? It's not the general models, all right? Don't do that. But and I think IBM has been doing that for quite a while. You can even use the AI to find ways to improve what's not optimal. Great, but these just don't go in there and thinking that you're just going to pull the humans out of this, because the humans are going to say, before you do that, understand what you're about to do, right? Because you're introduced. What I find in large organizations, this is just a structural problem because of hierarchies of orchestration and control and span of control. Risk, the definition of risk at the top, the middle, and the bottom, totally different definitions of risk, right? But what's not obvious, but humans intuit, is the cascade going up and coming down of that. And AI has no concept of that. It just doesn't.
Right. And you're running like a dual strategy here, right? You're commercializing in the open markets, Texas, New York, Ohio, Illinois, Michigan. And then you're waiting for places like North Carolina, where you happen to live, to catch up. How do you build a company on a map that is so uneven?
Well, I took all the lessons that I learned having hybrid teams all over the place, right? And then we're building out these grid edge devices that basically act as smart machines all over these different markets. So it's all about communications protocols, using experts in those markets who know those markets, who intuit that markets, and then using, I'll call it market sensors and sensing technology, some of it is AI, to understand the regulatory environment in each of the different, I'll say operating area, because sometimes it's a state, sometimes it's a region. And then we keep this sensing loop, right? And the sensing loop gives me the second operating system, which is basically I'm learning from all these other different markets that I play in, what's going to work, what's not going to work. And that allows me to be a good partner for the states that are trying to figure out what they want to be, what kind of market they want to introduce. How are they going to conform to certain regulatory requirements that are being mandated, but they're dragging their feet on because, frankly, to implement it is a mess, right? So that partnership, that second strategy, allows me to build relationships so that we're ready to go when they're ready to go, and we become their natural partner in the future.
When I was in the deregulated markets running Glacial Energy, I watched this whole thing mature and consolidate. We eventually ended up selling the energy company to Constellation once the competitive market really showed up in a big way. Where are we in that cycle now? And what does maturity mean for someone building this kind of a structure today?
This was a fascinating revelation that I stumbled upon, and there's so much great work out there that you can kind of dig into. This guy named Adizes, who studies the life cycle of business. I never got to meet him, but I got to sit at the feet of several of his pupils, and there was an interaction between his pupils and another group, which was studying natural patterns in nature and how much of that applied to markets. And what came out of that is that there's this cycle that's happening with every single thing on the planet. Every single thing. Humans, cells in humans, trees, businesses, departments, all the way up to the full enterprise, all go through this cycle. And once you can see it, you can't unsee it, which is good and bad. But it also gives you basically some levers and some instruments for you to hold up. And it lets me see that pattern that you're talking about, because that pattern repeats itself over and over and over and over again. So every deregulated market runs the same arc. You have messy early competition, right? Everybody's jumping in with their ideas. Strangely enough, Pareto principle falls out in nature, which is basically 80% or more, roughly around 80%, 1 sigma, 2 sigma, of those ideas are unviable. It's messy, and that's the way innovation is, and you just got to get over it. It's going to consume a lot of capital, and all that investment we're seeing right now in this market with AI, with power systems, with expansion of the grid, with all these big data centers, and then modernization of just all the infrastructure that's been overlooked for about 30 to 50 years, depending on where you look. All it's coming together, converging together in these big super cycles, right? And what happens is it get messy. You figure out what's going to work, the ones that can adapt fastest, which we learned from both nature and from the dot-com bubble where Web 2.0 came along. The ones that can adapt fastest are the ones that survive. And they end up eating everyone else because the capital runs out because it doesn't make sense for the ones that don't have viable businesses. And that capital investment then shifts and starts to snowball into consolidation. And then you get a stable market again, right? But then the market will stay stable only as long as new innovation doesn't enter. The moment that something disruptive comes along, you start the cycle all over again. So if you know what's going to actually disrupt the market, you can start placing small bets, pivot, stay the course, pivot, stay the course, all the way through it. And it's a discipline that an entire enterprise has to have to be an adaptive organization and have agility. And most organizations just either they're not incentivized, the regulatory environment, they don't know how to navigate that in such a way to basically be a good partner, let the regulatory, which is always going to stay right behind you. They're not going to be in front of you. So you got to stay just ahead of them and pull them along because they're basically looking for what comes out of that messiness. And that becomes their policy, right? So just, once you understand that cycle, it basically allows you to instrument where to go, how to work with the incumbents. You can have some pretty good predictions about what's going to happen to some of those incumbents. I know one technology company that I'm betting on won't be around in 2 to 3 years. And it's a major company. A company that we just struggle to believe that it won't be there. It won't be there, at least not in its current format. The name may be there. Some licensing will be there from their current intellectual property, but the company that we once knew and loved will be gone. And we saw that. With the first round of deregulation in most of the power markets. Those companies are not the same companies. They may even still have the same logo there, but they are absolutely not the same companies.
And I can attest to that because I ran one of the largest, and we were very early in the business. Glacial Energy. We were the first company to be in every location. I had 400 salesmen. I was in every state until California opened. We got crushed in California because some of the senior people didn't understand the market that I understood, and it killed us. And we ended up having to sell the company because we did not adapt to the fast changes that Constellation, First Energy, a lot of companies with a lot deeper pockets than we had changed the rules of the game. And
they did.
So you're absolutely right. I mean, I watched First Energy, which was the primary utility in Ohio, go bankrupt because they felt that by selling power below market to capture the customer would save them in the long run. And of course, that Japanese model never worked in the 80s. I have no idea. And I just had to stand there and let them take client from us because I wasn't going to sell power at a loss. First Energy was capable of it. And they went bankrupt and we sold the company. So
what's interesting, Wall Street understands this cycle really well. They don't talk about it that much, but they understand it really well, which is why you see them oftentimes take what looks like a scorched earth approach, right? Where they're just going to extract until something runs out of steam, and then they take their money and then go somewhere else. But what they're really doing is they're setting up that cycle to where the cycle overlaps with the collapse part overlaps with the consolidation just enough that it continues return on assets invested, right?
So I spent my whole life on Wall Street, and I can tell you that that model has been in existence. I mean, you can look at companies like Kodak.
Yeah,
Kodak didn't want to create a digital camera because they made film. They went bust.
right.
Xerox went bust. I mean, and these are companies that had to go bust because they could not adapt and improve their business model, like what you're talking about doing right now. And
Right.
you're developing this model, but who's actually buying this? Tell us about the customer who wakes up and decides they need what you're building.
So picture a manufacturer whose line can't go down, right? You got 3 shifts running, a brief outage scraps a batch, right? Just totally blows a batch. Now, manufacturers in Industry 4.0, they're smarter about getting very small batch size, trying to get that close to that ideal single unit flow that, and okay, some people can achieve it, but it's pretty rare these days. So, but that batch, that's money. That money's gone if that machine just goes out right during the middle. It blows delivery commitments. It blows up the supply chain buffers on either on the delivery side or on the supply side. A lot of manufacturers that I was talking to back 3-4 years ago that were really buying into, we're going to build back in America. They wanted to build these very lean shops, and they are ultra high tech. And when I say blow a batch, it may not just blow a batch. It may blow out a workstation because the automation there, the mills, the milling machines, which are so amazing, the lasers are so amazing. It may actually take that machine out because those things they're not too resilient when it comes to, if you go down like 5-10% below of their expected voltage or amperage, it's toast. You literally fry the circuits running all of these electronic controlled systems, right? Back when they were mechanical systems or pneumatic systems, it didn't matter as much. But now that everything's gotten so smart, they have to have resilient power. Now, the problem with that is that costs them a lot of money to have that buffer and that power purchase agreement with the local utility. I basically take the difference, the gap of that, and say, let's figure out what your investment looks like for us to run a virtual power plant there, do a certain degree of on-site generation and storage to remove that risk and remove the cost of the additional costs of what it takes to run your mill with that much buffer on it coming from the power grid. So that's one. And there's a lot of issues there in certain markets because to do that, you have to have a certain amount of assumptions around infrastructure that's available and supply chain that's available. And I'm finding that's actually kind of tough in some markets. I'll take the market here in North Carolina as an example. We found, and it's now start in that scaling stage, right, where we can use natural gas and solar. So we use solar with natural gas. Solar takes the natural gas, turns it into hydrogen and water. The hydrogen gets used in the hydrogen fuel cell, which also produces water. The water from both go into the plant to be used in the plant, creating a closed loop system, right? But there's a whole lot of natural gas pipelines that go through North Carolina. But there's not a lot that actually stops here. And the regulatory environment is such that we can't really take spurs off of the big pipelines very easily here. So there's things like that you got to like plan around. How are you going to do that? Well, that rules out certain technologies and also makes the solution unviable. Someone like that who we can work with in a market that can be viable, that's a good customer for us. And that economic model works out. Another one that I've already seen successful in Europe, and I keep wondering why it's not being done here, which is why we care about it, which is you take your big box strip malls, and big box strip malls have huge surface areas. They have huge parking lots. Those parking lots, the asphalt of the parking lot itself raises the ambient temperature about 2 degrees to 3 degrees Celsius just because of the parking lot. We're paying energy costs to cool the building that's getting heated an additional 3 degrees Celsius because of that parking lot. What would happen, and Europe already proved this out, if you just put solar over the top of everything, put solar over the top of all of the roofs of all of the big box, and then use that to offset the energy costs. Well, now we're taking, something that it has a secondary effect, which is that asphalt down below that is now no longer creating the 3-degree increase, which causes the additional demand and cooling. So not only are we containing the cost of the energy, but we're actually getting a secondary effect by removing demand for the energy to cool all of those buildings off. So that's another person who makes a great client for us. The final thing is like bringing all that agile software thinking, working with someone who's going to let us not do a big bang, because we don't want to do a big bang. We want to actually prove it out, not in a pilot, in the traditional pilot way, but literally incrementally, because we want to actually use hypothesis-driven construction techniques, which basically says, is this economic model that we had as a theory that we've proven over and over and over again on paper, is that really going to work? And being able to cut off the sunk costs fast, because frankly, I don't want someone to have to invest a ridiculous amount of capital in something that isn't going to actually give the payback.
Well, this is exactly the conversation I had hoped for. Two operators, different machines, same lesson. The tool is only as good as the system you pointed at. Where should people go to find out more about you and your company, Calatüré, and what you're building?
Well, ideally, I'd say our website. It's constantly evolving. So if you go there and you get the famous 404, well, that's because there's something new coming. But I would say go to our website, calatüré.com, and you'll see both the technology company that's basically building products and services, and the other side of that, which is, the energy company. And, people can actually, so I built something called the product operating model in the Agile community years ago, and my hypothesis was completely wrong. But eventually I found the real product operating model, and part of that product operating model was recognizing that buying COTS solutions, except for back office stuff that really is just a sunk cost, doesn't make any sense anymore, because AI and software libraries and so forth. So basically anything that I'm using inside the company is licensable as a platform by anyone. So that's actually the third leg of the strategy that we really haven't talked about. But if you go to the website, you'll be able to see that.
Excellent. So for our listeners, the line of this whole conversation is the subject of my new book, AI Won't Fix It. Same argument Devin makes about the grid pointing at your revenue operation. AI amplifies what you already have. If what you have is a leak, it leaks faster. That's the show. I'm Tony O'Brien. This has been the O'Brien Brief. Devin Hedge, you've been fabulous, and thank you for your time.
Tony, it's been a pleasure. I can't wait to see the reception of your book, because I think the insights in it are well earned.
Appreciate it.
Well earned. Yeah.
Thanks a lot. And have a great day, everybody.